Day 9 of 90. Today we are building network scanning tools using raw Python sockets. Before you ever run map on an engagement, you should understand exactly what happens at the socket level when you probe a port. We are going to build a TCP connect scanner, add banner grabbing, handle timeouts properly, and generate structured output you can actually use in a report. Let us start with TCP connect scanning. The socket module gives you connect_x, which returns an integer error code instead of raising an exception. A return value of 0 means the three-way handshake completed and the port is open. Anything else means closed or unreachable. The advantage of connect_x over connect is that you avoid try-except overhead on every single port, which matters when you are scanning thousands of them. We set a timeout with setTimeout so we do not hang indefinitely on filtered ports. On a local network, 1 second is plenty. Over the internet, you might need 2 or 3 seconds to avoid false negatives. Now here is the problem. Scanning ports one at a time is painfully slow. If every probe takes up to 1.5 seconds and you are checking 1024 ports, that is over 25 minutes of just waiting. The fix is threading. Python's concurrent.futures module gives you a thread pool executor. You submit all your scan tasks, and the pool runs 50 of them in parallel. Results come back as they finish through as_completed. The entire 1024 port scan drops to about 30 seconds. This is a connect scan, not SYN scan, so each probe completes the full handshake. That means the target's logs will record every connection, which is fine for authorized testing but worth knowing. Once you know a port is open, you need to identify the service. That is where banner grabbing comes in. Many services send an identification string the moment you connect. SSH servers send their version, like SSH 2.0, OpenSSH_8.9. SMTP servers send a 220 greeting with the mail server name. For HTTP, you need to send a GET request first. The implementation connects to the port, sends a protocol-appropriate probe, then reads up to 1024 bytes of response. That banner string is gold for security assessments because it maps directly to version-specific CV entries. If you see OpenSSH 7.4, you know it is vulnerable to user enumeration via CVE 2018-15473. Not every service sends a banner voluntarily though. Some require a specific request to elicit a response, which is why matching the right probe to the right protocol matters. Timeout handling separates amateur scripts from professional tools. I built an adaptive scanner that starts with a 0.5 second timeout. If the port does not respond, it retries at 1.5 seconds, then 3 seconds. If all attempts fail, it marks the port as filtered rather than closed. This distinction matters because closed means the host sent back a RST packet saying nothing is listening, while filtered means packets were silently dropped, probably by a firewall. The adaptive approach keeps scans fast for responsive targets while still catching ports behind packet filtering firewalls. You avoid the worst case of using a 3-second timeout on every port when most respond in milliseconds. Finally, structured output. Printing results to the terminal is fine for a quick check, but real assessments need machine-readable data. I generate a JSON report with the target IP, timestamp, and an array of open port objects that include the port number, protocol, and banner text. This format integrates with downstream tools. You can diff2 scans to detect newly open ports, feed results into a vulnerability database query, or generate client-facing PDF reports. The key fields are port, protocol, state, and banner. Add a timestamp and you have a scannable, diffable, searchable record of every assessment. That wraps day 9. We built a complete scanning toolkit from raw sockets covering connect scanning, threading, banner grabbing, adaptive timeouts, and structured reporting. The important takeaway is that every commercial scanning tool uses these same socket operations underneath. When you understand the socket layer, you can read map output and know exactly what happened on the wire to produce each result. Tomorrow on day 10 we build on these fundamentals with more advanced network analysis techniques. See you then.